Hello everyone, and here's another differential equation question. Let's have a look at this one. A scientist is studying the population of mice on an island. They love these islands in Edexcel, especially in further maths like bear and fish on the island and oh my goodness. Another island, here we go. The number of mice n in the population t months after the start of the study is modeled by that equation. Find the number of mice in the population at the start of the study. So in other words, that is when t is equal to 0. So the number of mice when t equals 0 is going to be 900 over 3 add 7, and that is going to be e to the 0. So that is going to be 900 over 3 add 7, so 900 over 10. So there were 90 mice on the island at the start of the study. Show that the rate of growth dn by dt is given by that expression. So I think first of all, let's write n as 900 times by 3 add 7 e to the minus 0.25t. I think that would be useful. And we're now going to differentiate this using the chain rule. So dn by dt is going to be 900. And when we differentiate this, the 3 is going to disappear. We're going to have the e to the minus 0.25t. This, when we differentiate this, is going to be multiplied by minus 0.25. Okay, so we're going to have going to be 900 times by 7 times by minus 0.25, and then times by e to the minus 0.25t. So what's happened is the constants remain there and that power's come down. Okay, now, so this is a composite function. So our outer function is technically something to the minus 1. Okay, so we need to times by the power that's there and then lower the power by 1. So we need to have minus 900, and then this whole thing, the 3 add 7 e to the minus 0.25t. needs to go to the power of minus 2. So what we've done is, using the chain rule, we've times by the power that's there, the minus 1. We've lowered the power by 1. So we've now got the something to the minus 2. Then we've times by the derivative of the inner function. The 3 has disappeared, and 7 e to the minus 0.25t goes to 7 minus 0.25 e to the minus 0.25t. So therefore, our dn by dt is in fact the minus and the minus there will cancel out. So that gives us 900 times by 7 times by 0.25 times by e to the minus 0.25t all over 3 add 7 e to the minus 0.25t all squared. That's just bringing that minus 2 down. Okay. So that's our expression for our dn by dt. Now, for this next bit, there are various ways of approaching it, and I'm settled on a version that I think is quite nice. Let's have a look, first of all, and think about which bits we can replace. So I feel like we're going to replace the 7 and the e to the minus 0.25 first. Okay, so let's have a look at our original equation. So n is equal to 900 over 3 add 7 e to the minus 0.25t. Now, if we swap over that one and that one, so that we write this as 3 add 7 e to the minus 0.25t equals 900 over n. That's quite nice. And then we can take 3 away from that, okay? So when we subtract 3 from that, we get the following. So we subtract 3 from this. This gives us now 900 over n minus 3 is equal to 7 e to the minus 0.25t. Okay, there we go. So that is a nice way of replacing 7 e to the minus 0.25t. So in our expression here, I'm going to replace the 7 times e to the minus 0.25t with 900 over n minus 3. This is quite an efficient way of doing the whole thing. So what we end up now with is that dn by dt is now equal to 900 times by 0.25 times by 900 over n minus 3. Okay, so in that dn by dt, you can see that that and that have been replaced by that. Quite nice. Now we're going to do a similar argument here as a way of getting rid of this 3 add 7 e to the minus 0.25t. Again, if we go to this original version of the equation and we swap over these two, then we can see that we can replace 3 add 7 e to the minus 0.25t squared with 900 over n squared. So we've referred back to this original expression to help us simplify. So that means that the denominator here can be replaced by 900 over n squared. So 900 over n all squared. And there we go. So we've now got something that's going to looking quite promising, I think, actually. So let's just simplify this now then. So we've got 900 times by 0.25. 900 times by 0.25 is 225. 225. And then we've got 900 over n minus 3. Let's just work out what this 900 squared is. So 900 squared is, oh my goodness, rather large number. So it is 8 1 and 4 zeros over n squared. Now remember, dividing by a fraction is the same as timesing by its reciprocal. So this is the same as 225 times by 900 over n minus 3 multiplied by n squared over the 810,000, like so. So all I've done is just say dividing by this is the same as timesing by its reciprocal. Okay, so we can now simplify the 225 over the 81,000. So 225 divided by answer is, oh, we're starting to look good now, 1 over 3,600, which is super promising, I think. And then we've got times by n squared times by 900 over n minus 3. A factor of 3 can be removed from the 900 minus 3. So that could be 3 over 3,600 times by n squared times by 300 over n minus 1. And then 3 over 3,600 is going to be the 1 over 1,200 that we need. So that is 1 over 1,200. And then let's expand this bracket now. So we're going to have n squared 300 over n minus n squared. Okay, so that can cancel and that can cancel. So that gives us now, we've got it now, because we've got 1 over 1,200 times by n times by 300 minus n squared. So all we do now is just literally factorize out the n. So we've now got n times 300 minus n all over 1,200. And that, I think, is like the nicest way of simplifying that one. I mean, I say nice, it's quite tricky, but it is a question that's quite near the end of the paper. So that is our part B done. Show that the rate of growth can be expressed in that form. Now, this bit I always think students in my experience find this next bit of the question quite confusing. It says, find the rate of growth is a maximum after t months, okay? And it says, find, according to the model, the value of t. Now, let's look at this expression. So this is our rate of growth, okay? Now, if we were to look at this, you can see that when n is equal to 0, so let's say this is our rate of growth, dn by dt. and this is our n. Now, when n is 0, we have 0 rate of growth. And when n is equal to 300, we would have like 300 minus 300, we'd have 0 growth, okay? And then you'll observe that when we expand this n times 300 minus n, we've got a negative quadratic, okay? So actually, the rate of growth looks like this. So we're 0 at 0, and there's no growth at 300. So by symmetry, the maximum rate of growth is going to occur when n is equal to 150, okay? Because we have a negative quadratic. So what we're going to say is the mark scheme says we should deduce that the maximum rate of growth occurs when n is equal to 150. And it says, find according to the model the value of t. So the maximum rate of growth is occurring when n is 150, okay? So we then need to take that value of 150 and see what the corresponding t value is at that time. And in order to do that, we just can go back to the original equation. So we're saying that 150 now is equal to 900 over 3 add 7 e to the minus 0.25t. We're just going to rearrange this in a similar fashion to what we've done earlier in the question. So 900 over 150. And then we're going to take away 3 and divide by 7. So e to the minus 0.25t is equal to 900 over 150. And we're going to subtract 3. And then that whole thing is going to be divided by 7. So let's just see what that gives us. So 900 divided by 150. Take away 3. Okay, divided by 7 is 3 over 7. So we get that e to the minus 0.25t is equal to 3 over 7. So there minus 0.25t is equal to ln of 3 over 7. And then t is therefore equal to 1 over minus 0.25 ln 3 over 7. And let's see what we get for that. So it's going to be natural log of our answer. And then we're going to divide the whole thing by minus 0.25. And that gives us 3.389. So t is equal to 3.389. Now let's just sense check this. It says, find according to the model, yeah, t is in months. So I think we can just say that actually t is going to equal 3.4 months. So t is 3.4 months there in that one, okay? Focus in a little bit. Okay, so t is 3.4 months. Now, according to the model, the maximum number of mice on the island is p. State the value of p. Okay, now this, again, is such a super popular idea in questions of this type, okay? And what we need to do is just, for this last bit, we just need to revisit and look at the original equation, okay? So n is equal to 900 over 3 add 7e to the minus 0.25t. And I really can't emphasize this bit enough. It seems to come up almost every exam season. We have got here our e to the minus 0.25t is going to be an exponentially decreasing curve, okay? So as time increases, this decreases. So basically, as time tends to infinity, e to the minus 0.25t tends to 0. So as time gets bigger and bigger and bigger, this term becomes 0 and effectively vanishes. So therefore, n tends to 900 over 3. So therefore, the population of mice is just going to tend to 300 in the long term. Okay, so the value of p is that p equals 300 is going to be the predicted value for the long term, the number of mice on the island, which they're presumably sharing with bears and fish and foxes and rabbits and goodness knows what else from various. There must be an imaginary world out there somewhere where all of these animals living in harmony on this fictitious island. Okay, I hope that you found that question helpful, and I'll see you in the next video.